uniform, my position, lunchbox.
In this video, we are going to learn about property 2 of binary operations, commutative. A binary operation star defined on the set R of real numbers is commutative if A star B is equal to B star A for all A, B are elements of real numbers. Nota bene. Common binary operations which are commutative are addition and multiplication. 3 plus 2 is equal to 2 plus 3, which is equal to 5. Therefore, addition is commutative. 3 times 2 is equal to 2 times 3, which is equal to 6. Therefore, multiplication is commutative. 3 minus 2 is equal to 1, whereas 2 minus 3 is equal to minus 1. Therefore, subtraction is not commutative since we got different answers right here. 3 divided by 2 is equal to 1.5, whereas 2 divided by 3 is equal to 2 over 3. Therefore, division is also not commutative. Before we consider our example for this video, I want to give you the solution to the previous video's question. So the question here, so this is how you could find the solution. But it's advisable to prepare the Cayley table, and after doing that, you then check if there are no new elements in the yellow area here. In this case, we have new elements which are not in set S. Therefore, the set is not closed under this binary operation defined here. Okay, now let's consider example 1 here. We have our set G is equal to 1357 right here. Show that G is commutative under multiplication modulo 8. So for our solution, we are going to use the Cayley table as well in this case. So we construct this Cayley table. Those who don't know how to construct a Cayley table, I suggest you watch the video that I made previously on the Cayley table, on how to construct the Cayley table. I explained it in 2 previous videos, the one for testing for closure and the one for how to construct the Cayley table. I will put the links in the description. Now, after constructing the Cayley table, how then do we determine if this set G is commutative and multiplication modulo 8? Well, we have our major diagonal with these numbers 1, 1, 1, 1 here. This is our major diagonal, right? So what we need to do is we want to check the fastest way to check for commutativity is to check if the elements are reflected in the major diagonal. For example, if we check here, 3 here is reflected to 3 here, 5 here is reflected to 5 here in the major diagonal, then this 7 is reflected to this 7 here. This 7 is also reflected to this 7 here. 3 is reflected to 3 here. Therefore, since elements are reflected along the leading diagonal, therefore the set is commutative. Or you could use this method right here. We just take any 2 members right here, and we let the other number be A and the other one be equal to B. Then A star B must be equal to B star A. In this case, A star B, we got 3 star 7, which is 5, and B star A is also 7 star 3, which is equal to 5. Okay, these answers we have calculated them already in the Cayley table. For example, 3 star 7 is 5 right here, and 7 star 3, 7 star 3 is 5 right here as well. So we were just taking our answers from the Cayley table. Therefore, since A star B is identical to B star A, which is also equal to 5, therefore G is commutative under multiplication modulo 8. This is another method that you could use. Now, I want you to attempt this follow-up exercise right here. Until next time, thanks for watching.
Chocolate Tavhura, Tavhura,